Let's examine the centrifugal compressor, which uses non-positive displacement vapor compression for compressing large amounts of refrigerant and are typically used in very large capacity cooling systems. A centrifugal compressor has three basic components: an impeller, a diffuser, and a volute casing. Large capacity centrifugal compressors may have two or more impellers or stages in the same casing. Centrifugal compressors are usually driven by hermetic electric motors. However, open-drive centrifugal compressors are also available for applications using steam turbine, gas turbine, or engine drives. The impeller is a rotating circular disc with curved blades that is driven at high speed by the electric motor. As the impeller rotates, it moves refrigerant vapor from the suction opening in its center to the outer edge using centrifugal force. The vapor enters the suction at a relatively low velocity and leaves the outer edge of the impeller at a high velocity. This means that the impeller transfers its rotational energy to the vapor, but high velocity does not relate to high static pressure. To achieve the desired pressure increase, or compression, the vapor must be slowed down, converting its velocity pressure to static pressure. That's where the diffuser comes in. As high-velocity vapor moves radially outward through the diffuser, the flow area increases, slowing the vapor and increasing the static pressure. Some centrifugal models have diffusers with vanes or pipes which change flow direction and further slow the vapor. The volute-shaped casing collects the slow-moving, high-pressure vapor from around the diffuser and conveys it to the discharge connection of the compressor. Inlet guide vanes control a centrifugal compressor's capacity. These movable vanes are located in the suction opening. With vanes turned fully open, the compressor produces its full cooling capacity. As the vanes are closed, they reduce refrigerant flow through the compressor, reducing the capacity of the refrigeration cycle. In addition, capacity control in a centrifugal compressor can also be obtained by changing the rotating speed. This concludes our segment on the mechanical non-positive displacement vapor compression cycle using a centrifugal compressor. Please take a moment to complete the following learning activity. To continue, make your selection.